Wonderful. Okay, so as you know, SiLA sees itself as a part of a broader ecosystem to make lab informatics easier and to help people wrangle all the different challenges that come from the heterogeneous landscape of instruments, data sources, data consumers, and the different tools that make up a scientist's workflow on a daily basis. And at SiLA, we also believe that we cannot and we do not want to solve all the problems of lab informatics, but we want to collaborate with best of breed partners in order to serve our mutual stakeholders. And our relationship with AnIML is one of those examples where this approach was really able to bear fruit. So here is an update on where AnIML is at the moment and what's new. And obviously we can't go into all the details here, but we can give you a bit of an idea of where things stand and some pointers if you want to learn more. So most of you will probably know what AnIML is. It's an XML-based data format for analytical and biological data to document the execution and outcome of lab experimentation. And it comes from ASTM. And due to the fact that AnIML looks after the data, it's very complementary to what we do here at SiLA, where SiLA is about communication and in getting different systems to talk. Well, once we've done that and we've gotten the systems to do what we want, we need to document what happened. And that's where AnIML comes in, making a very accessible data format a part of the picture so that the data can be easily moved around using protocols such as SiLA. And AnIML also has a very active community. So there are frequent conversations. There is the weekly meeting, which actually is supposed to take place right now. So every Tuesday at 10 Eastern. Today, we're not having it because obviously we are all here. There is a monthly summit, which we use to provide an update to the wider community of stakeholders. So if you want to follow casually what's going on, this is a good format to join. And that's on the first or second Thursday each month at 11 Eastern. And when we're able to travel, there is a North American and a European face-to-face meeting once a year and respective workstream meetings for the individual things. So I'd like to highlight 3 things that the AnIML community is currently working on. As you know, the format has been finished. Last year, there was a big effort on putting together a documentation package that makes it easy to discover and to adopt the functionality. But now it's also about adoption and about forming partnerships to ensure that through multipliers, we can reach a critical mass and solve relevant problems. A standard is much, much more than just a specification. And that's what we're trying to do here. And I'd like to give you 2 examples that have been also quite visible recently. So the first one is the CDS Interop initiative, where we have a joint initiative between SiLA and AnIML for bidirectional integration of LIMS and chromatography data systems. So to put a bit of a different spin on this, SiLA will work great in lab automation, but it also works great in integrating traditional analytical equipment. And that is where that's where you will see 2 examples now from that category. And so how do I integrate chromatography data systems traditionally? Well, you have probably all heard the story before. The LIMS would write a work list file to some type of a transfer folder, and then it starts monitoring a result folder to hoping that the result will come back from the instrument. And then you've got in green what the instrument software does. It keeps watching that transfer folder for new work list files, picks it up, performs the measurement once the user presses go, and then later writes the result file into a result folder. The LIMS will then pick it up and imports the content. Now, this is kind of the status quo. There are a couple of complications here because the file formats for work lists and reporting are typically instrument specific. Those formats are fragile and they can change, and the files can be manipulated while in transit. And we never know if a file is complete or whether we're still busy writing it, and there is no robust error reporting. And so that was the first bit where the CDS Interop initiative came together, where we combine SiLA 2 to introduce a communication layer between a LIMS and a chromatography data system, so that I can actually use all those nice features that SiLA provides. So SiLA 2 discovery, I can inventory the instruments and the services that are available, and I can learn how to talk to them, since they can describe the capabilities that they have and the commands and the parameters and all of this. And that way, a LIMS can learn how to communicate with those systems without ever having seen it before. And when you combine SiLA and AnIML here, the LIMS can discover, on the one hand, what the SiLA features are. So how can I send commands, and how can I check the status on my batches on the chromatography data system. But at the same time, I can discover what the data will look like that the CDS returns once it's done with the run. And that way I can build sophisticated integrations without custom code, which is a novelty. And then I'm in a position to control my instrumentation, submit samples, get status updates, and the service will then return a complete and traceable AnIML data package describing what that did. And if you're interested, there is actually a poster that was presented at SLAS, which describes this effort and the specific artifacts, and also gives some implementation examples. Most of these implementations were based on Chromeleon on the CDS side. There is now some additional work going on to broaden that out to Empower. And on the client side, there have been several LIMSes, predominantly LabVantage and Labware, who have been active in that space. And we'll also share this poster. I think it may even already be on the download page on the SiLA website. So this is one example where you can take a traditional lab workflow in an analytical world, and you can make it more sophisticated using SiLA. And SiLA is all about solving problems, the real world problems in a lab environment. And I'd like to talk about another initiative which has been very active over the past couple of months, and it's a collaboration with the European Bioanalysis Forum, which was also about bidirectional integration of instruments, in this case LIMS and LC-MS, but in a regulated bioanalysis environment. And here you had a data integrity issue, because the transfer of work lists and the transfer of results was always done using text files, and that obviously is a mess. So what happened was that the EBF community actually had a couple of folks who were working on data integrity, and they thought, we need to put out a white paper and publish that says what are the problems in data integrity in regulated bioanalysis. And they proposed that the community should get together and propose a generic data transfer process for LC-MS data. And then what happened was a group of vendors got together with these end users, and they thought about, okay, how can we improve that process? And here we have a very similar process. You have your LIMS system, it creates a sequence file, it gets stored somewhere, and then the instrument picks it up. And then after it's done, it creates some export text file, which then gets put somewhere, and then the LIMS picks it up. And all of that obviously is a little bit difficult, because you don't know what's happening here. So just with the CDS interop problems, you have the same ones here. Now, here, the thought was, can we do something quite quickly? Obviously, everyone likes the idea of fileless integration, but that may be too big a piece of the pie to bite off at the moment. So they started thinking about how can we make a file-based approach more secure. And so that's where the thought was, okay, let's replace the text file with a digital signed XML file. And we used the AnIML format in order to do that, so that the LIMS system can create a sequence file in AnIML format and use the digital signature capability of AnIML to secure the content, so that the sequence can clearly be attributed to the LIMS and cannot be manipulated without it being detected. And then the instrument software can suck that in, do what is necessary, and then you have the round trip with an AnIML document that now adds the result information to the sequence information that was already in it, digitally signs that as well, and hands that back to the LIMS. The LIMS can then check, has that data been manipulated by confirming the digital signature? And that way we can prove that the flow of data has not been interrupted. And that is obviously a beautiful data integrity gain that we were able to bring here. And the nice thing is when we use AnIML, we get the XML digital signature standard out of the box, which comes from the World Wide Web Consortium. AnIML didn't invent that, it uses that. So that way, a record becomes attributable, so I can tell who made the signature, I can see has been tampered with, I can have multiple signatures on the same document, on different parts of it, I can automatically validate that to follow my SOP, and a couple of other things. And since it's XML based, it's really, really easy to read and write that. And that was actually being implemented. And kind of the three key takeaways the group found was we have better data security and data integrity. We have a widely adopted technology that many people are familiar with, and it's a vendor neutral approach with no cost involved. And there is a near zero impact on the current user experience. We're not doing anything different. And to acknowledge, there's been great participation from the end user community here to work on this. And those are the authors of this particular white paper. And then we had a working group that was composed of vendors and end users to actually put that together and to make it happen. And I'd like to show you a few examples of what that then looks like, because some vendors actually provided an implementation of this that they then also showcased. So here you can see that, so this is the Shimatsu LCMS software, which is now importing the sequence file that was provided by a LIMS in AnIML format, and then it executes the run. And when you then have your result, they have added an export menu entry here to say, I would like to export the current results. And at that point, the AnIML document is generated and gets placed there. And you get a little success message. And this is what it looks like. So you have, so this is an actual AnIML file that Shimatsu wrote. And if we now go ahead and we consume that using an AnIML tool, well, you can just do that. So here you can see what the BSSN software viewer can do with that. So you can just take that in, and here you can see the result table. You can see your list of samples and all of that. But what you can now also do is, oh, let's not use the BSSN software tool, but let's use Watson LIMS from Thermo Fisher. So here I have my sequence view in Watson, and the Thermo colleagues used their integration manager to map this into this XML format. And that way you could actually see how the sequence information then showed up in the XML content, and it can then be transferred, and then you import this AnIML document through integration manager into Watson LIMS, and this is what gets you the result information for the analytes. So another nice achievement of the AnIML community, and getting this to happen not just in a bubble, but together with vendors and with end users, because only that way we are going to solve real world problems. So I'd also like to acknowledge the great work that SciEx did. SciEx has done a fantastic job at providing a very complete export that they think is actually ready for compliant long-term archival, and that is also a good step into this direction. Now, where do we go from here? Well, what we already have is we've got a secure file exchange, but yeah, it's still file-based. And introducing SiLA as a transport layer can obviously add to that picture by making things more secure. Yeah, we no longer have a file that can sit around. The digital signatures on AnIML are already a good step, but here we can take it even further. And this is certainly one of the options that the working group is currently thinking about addressing, and we'll then take it from there. So with that, that was about the update from the AnIML side. Back to Oliver and Patrick. Thank you.